All right, in Concept D, we're going to be looking at a couple of different types of concentration calculations, and we'll go through examples of each. Concentration measures the amount of substance per unit volume. So if a substance is concentrated, that means it's relatively strong. You have a high amount of solute per solvent ratio. And so again, we're looking at the solute compared to the solvent or solution. If it's diluted, then it's relatively weak. That means we have a low amount of solute to solvent ratio. So again, diluted means it's a weak amount. So our first formula is for just simply concentration. This is the mass of solute divided by the volume of the solvent or the solution. Just depends on the information that you're looking at. All right. So our first practice problem for this calculation: what is the concentration of a solution prepared by dissolving 25 grams of potassium nitrate and 100 milliliters of water? So we're going to go ahead with our formula. Our solute is our potassium nitrate and water is our solvent. So we're going to fill in our given amounts and then simply divide and make sure we have our units reflecting what we use in our problem, so grams per milliliters. So 0.25 grams per milliliters is our concentration of this solution. Parts per million: the concentrations of very dilute solutions are often expressed in parts per million. So example, when they talk about the amount of different compounds, chemicals in water, such as arsenic, they usually express it in parts per million. So the maximum allowable concentration of arsenic in drinking water is 0.05 parts per million, or 5 grams of arsenic per every 100 million grams of solution. All right, so this is our formula. This is on the back of your reference table. We're going to be using mass of solute over mass of solution. So make sure we specifically have to use solution here. All right, so here's our practice problem. We have 0.0047 grams of ammonia. It's dissolved in 20 grams of water. Express this in parts per million. So remember, we have solute over solution. So the mass of our solution is both the ammonia and water, which is this total amount. So we're going to fill in the mass of our solute, which is 0.0047 grams, the mass of our entire solution, so the solute plus the solvent, so ammonia plus the water. And when we solve that and multiply by 1 million, we get 235 parts per million. All right, percent by mass and percent by volume, very similar. We're just changing whether we're working with mass or volume. The one big thing is you have to make sure that your solute and solution are in the same unit. So if I use grams, solute and solution both have to be in grams. If I use kilograms, they both have to be in kilograms. So mass of solute over mass of solution. So again, it has to be the solution, the solute plus the solvent. All right, so what is the percent by mass of a solution containing 12.3 grams of caffeine dissolved in 100 grams of water? Specifically, this is the solvent, so we're going to have to make sure again that we add these together in order to get our solution. So we can see there the mass of solution is the caffeine plus water, so when we fill this in, we need to make sure it's 112.3 grams in the denominator. So 12.3 grams divided by 112.3 grams. And when you solve this, you get 11%. So that is the percent by mass of caffeine in this particular amount of water or solution. Here's percent by volume, same exact thing except we're working with volume. We're going to again make sure that if we're using milliliters, we're using milliliters in both. If we change it to liters, then we're using liters in both. All right, so our practice problem: what is the percent by volume of a solution containing 18.2 milliliters of glycerin dissolved in 85 milliliters of water? And again, we can see we're talking about water, so this is our solvent. So we're going to have to go ahead again to add these to get the volume of our solution. Filling in our given values, 18.2 and our 103.2 that we calculated, we get 17.6% of glycerin in our entire solution. All right, so remember, this amount of solution equals the sum of the solute plus the solvent, and we'll talk about how to distinguish that in various word problems. All right, that is it. You are all set.